The Big Bang is the most widely accepted theory about the origin of the universe. Around 13.8 billion years ago, all the matter and energy in the universe were packed into a tiny, incredibly hot and dense point, smaller than an atom. Then, in a fraction of a second, it expanded explosively, creating the universe we live in today. But how did that hot ball of energy and particles evolve into stars, planets, and everything around us? Let's explore this cosmic journey. 1. The first few moments. A hot, dense soup in the first millionth of a second after the Big Bang, the universe was unimaginably hot, around 100 trillion degrees Kelvin. At these temperatures, regular matter couldn't exist. Instead, the universe was filled with a soup of fundamental particles like quarks, the building blocks of protons and neutrons, and gluons, which hold quarks together. These particles were moving so fast that they couldn't stick together to form anything stable. Fun fact, quarks come in 6 flavors: up, down, strange, charm, top, and bottom. 2. Cooling down. Formation of protons and neutrons. As the universe expanded, it began to cool down. By the time it reached about 1 millionth of a second old, it had cooled to a more comfortable 10 billion degrees Kelvin. Now, the quarks and gluons slowed down enough to combine and form protons and neutrons, the basic components of atomic nuclei. Fun fact, you're made up mostly of up and down quarks. 3. The first nuclei, the birth of hydrogen and helium. Fast forward to about 3 minutes after the Big Bang. The universe had cooled further to about 1 billion degree Kelvin. This allowed protons and neutrons to stick together and form the first atomic nuclei. Hydrogen, the simplest element, was born. Some of the hydrogen nuclei also fused to form helium. But the universe was still too hot for electrons to join the party and form complete atoms. Fun fact, today, hydrogen makes up about 75% of the normal matter in the universe. 4. The era of light. The universe becomes transparent. For the next 380,000 years, the universe was a hot, dense plasma of charged particles, protons, neutrons, electrons, and light couldn't travel far. It was constantly scattered by particles. But as the universe continued expanding and cooling, it reached a temperature of about 3000 degrees Kelvin. At this point, electrons could finally slow down enough to combine with protons and form neutral atoms. This era is called recombination, and it made the universe transparent for the first time, allowing light to travel freely. The light from this moment still exists today as the cosmic microwave background, CMB, a faint glow we can detect in all directions of the sky. Fun fact, the CMB is often called the afterglow of the Big Bang and is about 13.8 billion years old. 5. Dark matter and energy. The mysterious stuff. As matter formed and clumped together, something strange was happening. Galaxies were forming faster than they should have based on the visible matter alone. Scientists theorized that an invisible substance, now known as dark matter, was pulling galaxies together with its gravitational force. We still don't know what dark matter is made of. Even more puzzling is dark energy, a mysterious force causing the universe's expansion to speed up. About 85% of the universe's matter is dark matter, and 70% of the universe's energy is dark energy, meaning we really don't know much about the majority of the universe. 6. Stars and galaxies. The birth of light. Around 400 million years after the Big Bang, the first stars began to form. Clumps of hydrogen and helium gas, pulled together by gravity, collapsed under their own weight. This triggered nuclear fusion, igniting the first stars. As stars gathered into clusters, the first galaxies formed. Over billions of years, these stars began to create heavier elements like carbon, oxygen, and iron, the essential ingredients for planets and life. Fun fact, every atom in your body heavier than hydrogen was forged in the heart of a dying star. The cosmic dance continues. Today, the universe is still expanding, but it all started with a tiny, hot, dense point that exploded into existence. From chaotic energy and simple particles came the complex galaxies, stars, and planets we see today. And what's even more exciting? The universe is still evolving, and who knows what the future holds. This journey from the Big Bang to the formation of matter and energy is one of the greatest stories ever told, and yet there is still so much we don't know. The more we learn, the more mysterious and fascinating the universe becomes.